Hello fellow problem solvers, so they're going to be doing a problem from the 2022 Junior Bucket Math Olympiad, problem number 1. This is a good intro algebra problem that I suggest you try out for a minimum of 10 minutes. Ideally, half an hour to an hour. Not more than 4 hours, not more than 4.5 hours. Like that's if you were preparing for the Jbmo, not more than that because you want to try to get that, honorable mention, but I wouldn't say more than 2.5. Perhaps. So now without further ado, if you'd like to go along with us, take 5 minutes, put your first ideas out on paper. Now let's begin. So we need to find all pairs of positive integers a and b such that both of these are true. Now what is this? Like these are positive integers a and b. And if a times b is small, then there's like a small gap for this number over here. So that is going to be interesting. And we need to think about what sort of determines this gap over here. Now, A and B being positive, pause for a few minutes and ask yourself, what is the first thing you get? Sort of big picture. And for me, the first thing I get big picture, well, this is greater than 0, so A cubed is greater than or equal to B cubed, which means that A is greater than or equal to B. So with that in mind, what we have to do now is, okay, we have A is greater than B, but the question is, how much bigger is it, right? How big is A in terms of B? Can it be that much bigger than B? If A is if A is a linear combination of B, if A is 100B, say, or if A say, let's think about, say, ratio. Is A is equal to C times some R times B, right? Where R is their proportion, their ratio. Then we have R cubed minus 1 times A greater than or equal to 11ab less than or equal to 12ab. Divide things up. Okay, I'm still not really left with much, right? Yeah, this is still rb. Oh, this is actually times a times b. So I'd get left with 11a and 12a. And I have b here. So maybe there's something we can do with that. Maybe there's some bound we can say about how big R has to be, but it's not giving us anything for these. But it says, actually, let me put it this way. R can't be 10, because if A is bigger than B, then this R is bigger than 1. And if it was say it was free, let's look at it. If it was free, here we'd have 8 minus 1, we'd have 7b greater than or equal to 11a. Come on, that's not happening because A is greater than B. So R would have to be, actually I would have to be bigger than that, right? What I'm trying to get at here is, actually I'm trying to get at that this cannot be way too big, or could it perhaps? Maybe it can if A and B are both big. But it also shows we can't really just go ahead with this multiplication thing here. We have a B, we have an A. We can sort of put a bound on R, but not that much of a good bound. So let's try a different type of bounding approach. So if A is greater than B, I'm trying to think, what is this, right? This is going to be at least some 3b, or at least some 3a-ish squared. If b is a minus some t, then this is going to be 3t times a squared, right? We're going to have this on that side. And we're going to have 11a times b. But the a squared is bigger than the a times b, so this t cannot be too big. So this is the thing, how are we going to bound this? In general, is the question, this side is usually much bigger than this side, and it's much bigger than this side. It's this 12 and 11, they're not super large. So let's try to play around with some ideas. If we set, say, A is equal to B plus some t, and now what are we going to have here? Well, here we're going to have, what's it called, or we can set B to be equal to A minus t. Actually, this is just easier. It doesn't really matter. A is greater than B. So if I just plug everything in, I have, actually, if I just put, I have 11ab. If I just plug this part in, the b cubed will cancel out. I'll have this is greater than or equal to 3b squared t plus 3bt squared plus t cubed. and this is less than or equal to 12ab. Now, think about this part. Like this part, the a times b is sort of meant to be bigger than this, right? Generally speaking. Or maybe this does change something. I was thinking maybe initially that this would change something, so let's try that out. You want to try many different types of ideas when you're estimating this. I tried this part. It gives me like a bound for a, but it still tells me like a can be huge, b can be huge. But this gives me more concretely, and I can have t as an actual integer, positive integer in fact. Like a and b cannot be equal. So anyway, a is strictly greater than b, and thereby this is a strictly positive integer. But if I set b to be equal to a minus t, like what do I have? I have a cubed. I mean, this is a minus b times, right, this is a minus b times a squared plus ab plus b squared. Or in other words, I have a minus b, which is t. And then this is also a minus b squared plus 3ab. So this is t squared plus 3ab. So 3 times, yeah, which also incidentally makes sense. 3ab, so this is, yeah, times 3. I am going to go with 3a times a minus t. And this thing over here should be greater than or equal to 11ab, less than or equal to 12ab. So this number over here, 12ab, or 12a times a minus t times a minus t. Can I get at least some bound for t? Say if t was 10, what would I have? If t was 10, I would have 10 times 3a times 8. I'd have this side is much bigger than 12ab. Like I'd have something extra and 12ab. So that extra would be too much. So we can't really have that, can we now? So what do we want to do then? Well, let's try to estimate, say, how big can t be? And then like t is at least 1. It can't be, you know, if we have an upper bound, we have a lower bound of 1 already. So can we get an upper bound and then figure out, you know, we can maybe play around with some other answers if the bound isn't way too big. And now I invite you to try out, pause for 5 minutes and play around with these bounds. I'm going to rewrite everything here in a nice manner. And here's that. And here's everything written out again. So now what do we have? Well, now this side, so if t was greater than or equal to, say, 4, then we'd have a contradiction over here on this side. So let's now prove this. So we're going to say, so this part over here is greater than or equal to 3t a times a minus t, right? Because I'm just having like this t cubed term. I'm just like, let it go, let it go. And with that, I have 12 a times a minus t, 3, they cancel out. I get t is less than or equal to 4. So now t is at least 1. And on the other hand, it is going to be, what's it called? It's going to be at most 4. On the other hand, like t equals 1, like fails immediately because this is then just like 1 plus 3ab, 11ab, like the 1 doesn't cut it, it's not big enough. A times b is at least, say, 8, so 1 doesn't work. 2, we're gonna have 8, it's 8 plus 6ab. So I have 5ab less than or equal to 8. A and b would have to be sort of equal, right? AB is at least 2, it's at least a 1 and a 2. So 2 will fail as well. We can actually like write these things down, but I'm just, you know, saying them in a way, just show you a different way of thinking. So let me actually write that down. So this a times, actually we can now that we know t is less than or equal to 4, let's focus on this side of the equation, because if I pick a t that's like 3, and as long as a and b, as long as a times b is, so if this is 3, I get 9, I get 3ab here, and here I get t cubed. As long as a times b is roughly bigger than t cubed over 3, then I guess I'll be good. And it sort of feels like that should be the case. Maybe we need to check it out. At least we can now focus on this side because we found something because on this side. And now with that, what are we going to have here? Well, let's rewrite this as, so instead of, so I'll just use a and a, b, t, doesn't matter. So I'll say a times a minus t, and this times 11 minus 3t, 11 minus 3t. This thing is less than or equal to t cubed. Okay, so we said if t is equal to 1, this fails. If t is equal to 2, what happens then? So if t was equal to 2, we'd have, and this also I can say, I know this part to be greater than or equal to a times b is at least going to be 1 times 2. So this is at least 5. So I have 5 times 11 minus 3t, and this needs to be less than or equal to t cubed. So now what do I have? Well, if t was equal to, say, if t was equal to 1, immediate fail. If t was equal to 2, we'd have 5 times, what's it called? 11 minus 6. 5 times 5 is 25, and here I have an 8. So a contradiction for t is equal to 2. And for t is equal to 3, I'm going to get a 5 times 2. Okay, less than 27, that works. So now what do I have? I just have to check with t equals 3 and t equals 4, that. Like find a and b, which will work. And now I'll invite you to pause for the next 5 to 10 minutes and try to work with that. And here's the next step. And here's also something I want to mention as I'm going for the next step. Like, I'm talking about marking scheme because I had access to it. And that is that what you have to note here is that if you just state it right, if you only wrote down a minus b is equal to t, that's a point. Just by having that written, that's a point. Figuring out that this t is between 1 and 4 is, again, another point. And actually, no, that's 4 points. If you figure out that t has to be between 1 and 5, and not 1 and 5, 1 and 3, then that is going to give you 5 points. Because actually what we did there, we had like we had an extra t cubed, which you just said we had like this 12ab greater than or equal to t times t squared plus 3ab. And we just said this is greater than or equal to t times 3ab. But actually it's strictly greater than, because this is positive. So this is strictly greater than t times 3ab. And with that, once you cancel the 3ab out, you get t is less than 4. So we would need to check that, by hand, by writing it down. But here, we might not need to check it if we did it like that. Solving a equals 1 and 2 is another 2 points. And with that, let's go on to the a equals 3 case. I mean, not the a equals 3, the t equals 3 case. So when t is equal to 3, we have that a minus b is equal to 3. And now what does this become? This becomes 3 times a minus b, which is 9. And then plus 3 times ab, which is 3 times a times a. Or 3 times ab. I'm just going to write it as 3 times ab, see what I have. Less than or equal to 12ab, greater than or equal to 11ab. So what do we have? We have 27 plus 9ab, less than or equal to 3ab, less than equal to 12ab, greater than or equal to 11ab. Okay, get the 9ab out, and what do you have? You have 2ab, greater than or equal to 27, less than or equal to 3 times ab. A and b differ by 3. And now you could say something along the lines of this. A times a minus t is strictly increasing. Like a times b is less than a plus 1 times b plus 1. I know this. So if I increase a and b by 1, I'm going to get a bigger number. And given, or could I actually say even something more to the case? Could I say something along the lines of that 3 times this is less than 2 times this? No, I can't. I cannot say something like that, but I can say this is increasing, and if at some point 2ab is bigger than 27, then it will always be bigger than 27. So what do we have now? So a minus b is 3, and actually I should just write that down. So this is now a times a minus 3, and this is a times a minus 3. So now what do I have? Well, I can try stuff out. I can look at the quadratic. I can subtract 2 times a minus 3 if I want. I don't have the need to do that. I just go ahead and say, okay, let's say if a is equal to, so it's at least 4. So if a is 4, then here we would have 12 times 1, contradiction. It's not bigger than 27, so for a equals 5, we'd have 15 times 2 is 30, so equals 5. This side is good. And this side would be 10 times 2, which would be equal to 20. So this would work. A equals 5 works. So A equals 5, B equals 2 is a solution. Woohoo. What about A equals 6? So if A is equal to 6, then this side is what? 6 times 3 is 18, times 2 is 36. So this side is now over 27. And as we've said, then every other one bigger than 6, every A bigger than 6 will also be bigger than 27. And we can say that if A is bigger than 6, then A times A minus 3 is big. Actually, this is 2 times A times A minus 3 is bigger than 2 times 6 times 3. 2 times 6 minus 3, which is equal to 12 times 3, which is 36, which is bigger than 27. And so this side doesn't hold true for any other big A. And this finishes up the problem. So A is equal to 5, B is equal to 2 is the only solution to this. It was a weird problem when I saw it. I mean, different, unique. I like it in the sense that you haven't really, like, how much can you really prepare for this? Like, I didn't see that many problems that are of this form. So I was a really big fan. And it's a nice little problem. Hope you had fun solving it. And as always, thanks for problem solving.